Hey, you've seen some of my motorcycles on YouTube before, some hot rod strokers and stuff, and I did tell you I'd do a little expose, you might say, on some of the engines and bikes that are coming along. This is just a couple of different things that I'll show you. As you can see, it's got this is going to be a little hill climber, dirt drag or whatever, but it has a 47-degree crank in it, which will be firing in the same phase, so it'll be virtually a twingle, but just off by a bit. But anyway, regardless, I'll show you the crank. So this is 47 degrees. Remember I told you the bolt holes line up at 47, after 360, 47 and 99, and then in between I've done 70s and 76s. But that's a 47. This is a long stroke jobby, as you can see from this bolt here. It's through bolted. See how it goes all the way to the bottom just to keep the barrel together. The barrel is a 650 plus 80 pistons, see? 650 plus 80. And the conrods in this, as you can see, are those MAP 6.3 H pattern rods, or H beam, chrome moly steel, with the Norton steel crank centre in there. Because it's off centre, it has to be a steel crank. Okay, this other thing is a street tracker, kind of the Triumph version of that Norton I did. And remember I talked about zip barrels the other day. Well, here's a set that you can see a little bit more plainly. This one is 99 degrees. There are no rings on this. 47 over there, 99 here. With a set of the Rout big bore pistons that are available with those new kits. But in the case of this thing, I'm running the earlier style Rout rod, because this is a street engine. I'm not too worried if they're aluminium or not, but they're a good forged alloy rod. That was the first ones that MAP made. I'll show you a bit more about that in a minute. But that's another offset stroker and a Triumph. So the evolution of the conrod, I mentioned how I did a pre-unit early on with a Norton conrod, but you can see how big that knuckle is compared to one of MAP's chrome moly steel rods. It's going to take a whole lot more material and area to clean up to be able to get that bigger rod to spin. So obviously ditch that idea. Now in between, my first one that I did was a Carrillo after that, where my finger is. The next one in the evolution of it was some rods I had made by a machinist guy in Canada, Herb Becker. If you look on the YouTube and a young bloke McRae riding Herb's Nortons, he made still does I guess, very fast Nortons, but he also did a bit of stuff, and he helped me out with some alloy rods to do this 6.3 thing that I needed. And then along comes Marino after chatting with him a lot. Marino's at MAP, he started making these things, the longer 6.3 aluminium rods. And then this one here is a Norton rod. It's a little bit shorter, but it's the same thing as what's in those two in that Triumph engine there. They're the H-beam Norton rod, and chrome moly for either the 6.3, which actually works with a Norton motor as well to get a bit more dwell, so that you run a 6.3 instead of this stock rod in a Norton and a different piston that he supplies, and you get a little bit more torque out of the engine and a few more RPM at the top end. But anyway, so that was the rod that first done by him. Then these are the next stuff. He doesn't do these much anymore, but under street conditions, the motor that I showed you has got nearly 6,000 K on it, is running these, and oil pressure is good, so the ovality is still fine. There's no ovality basically because it's running good pressure, and you can tell with the Triumph because of the plunger pump. When you turn the engine off, the plunger pump seats against the ball, and there's no back feed, and everything, every leak, all the oil pressure that leaks down then is through the rod. And if it leaks down slowly on a hot engine, you can tell that obviously the rods are good. On a Norton you can't because it's a gear pump and it'll just automatically drop off at stop. But on the plunger pumps, you turn your engine off, you watch your gauge, and if it falls back nice and slowly, well then the rods are in good condition. That's simple. That's another good thing about an oil pressure gauge. Anyway, this is an oddball here. That one's a Norwich. Just get the shadow out of the road if I can. That's a Norwich crank I had done years ago, and it's a 80.5 for a Norton, in other words a short stroke, because Nortons are normally 89. This is a race crank that's going in an Atlas, and it's a 89mm with a steel centre. You can see that's been modified and where it's been lightened a little bit here and there. You can see the lightning notches here and the drillings to get it down to something reasonable. It has been weighed to carry a set of these sort of rods, these H-beam steels. This one here is a Norton offset, and this is going in an Atlas as well. One's going in a sidecar, one's going in a solo. But as you can see, this one is offset. So that's what I do, and you can see the right hand side, which is your timing side there. The right hand side leads the left hand side, and in this case 76 degrees. Now I don't talk about firing order so much, I just talk about crank lead. When I say 70 degrees, that's what I mean. This is 76 degree lead. Now the firing order of course is a totally different thing again. So, and that can be altered by the type of cams you use. And in the case of that thing over there, because I'm using really close fire Twingle cams, well, it's a 47 degree crank, no matter which way you look at it. And if you use the stock, normally modified cams for a V-twin, it would be a 47 degree, but the timing, the ignition timing and the cam timing is going to be two different things. So I always just use the crank angle. I don't worry about timing because it can change from one crank to another depending on the cams you use. This will be sounding more like, this is at 99 degrees, it will be almost indistinguishable from a Ducati when it's running. There is another one on the bench in there that's a 90 degree. But 90 degrees are a little bit hard because, as I said, the bolt holes, when you swivel on your pin down here, this down in here is your dowel, and you swivel the crank from there backwards, then the holes line up at 47 and 99, okay? So you don't have a crossover on the crank. You don't have a problem. Whereas this is 76 degree, it's in the middle. So there's no worries about fouling holes or bolt holes lining up. But at 47 degrees, that one and that one, those two there, back here a little bit, they line up. So you can put a stud through there and not have to elongate holes or anything silly. Same with the 99. It comes around a bit further and then it lines up with the next one. These are both 360 cranks, and they're both going in different Triumphs, and you can see this is a stock. This is going in a street bike, and it's this crank here, the crankshaft's flywheel is cast iron. That one's steel. This one is modified. You've got to modify here. You take the diameter down, you take the width down, and you chop quite a bit off the side here to help get clearance, and that's just part of it. But those are the three major things that you'll do to a Norton crank to get them into a Triumph. This one here has had a steel centre made. As you can see, it has welded and pinned flywheel, not just one or the other, but both. Hasn't been chopped off as much there as it could be yet, because I've had it balanced once, but I'm going to have to rehash the balance because these bob weights I put on are just a little bit too heavy. The crank weighs around 24 pounds, but it's going in a drag bike, and I don't mind if it's a little bit heavy, but I need to get better clearance on the side here in actual fact for the conrods, and I'm going to remove 1/8 of an inch off these and then rebalance. And when you do a Norton crank, you just leave the you leave the nut on the thread on the end here, still stays at that. See the left hand thread, and you just take the 6-start gear and you modify it to end up being a nut. Similar to that, but I do them a little bit different to that one too. So this is all bolted with Unbraco nuts and Unbraco studs, the Allen key studs. And it's a fairly, as you can see, it's all been upgraded to 3/8, so it's fairly substantial. And I hope it'll stay together for a little while. Just in a little 70s style drag bite with a 4-inch slick. Anyway, that's kind of what I do, and that's proof of what I do, and some of the engines you've seen and I talk about using using these sort of conrods nowadays. These are about the only ones I do use, and that's the sort of results I get, is what you've seen or heard on the YouTube videos that I've done. Alrighty, hope it's of some information to you if you're at all interested. Thanks for watching.